let's just go ahead and look at these. So, okay, so this is interesting. People came up with two different results here. So I'm just going to focus in on the pattern and ignore the sort of arc syntax for the moment. But somebody said, well, if I just want to look for these three, I can just simply separate them by the types of results. I don't remember off the top of my head whether we would need to have parentheses around the full cat part, because this might say T or A. Does anybody know, or did anybody try that out and see whether that mattered? No. Doesn't matter? So this is sort of going by full enumeration. I asked for three things. We just said look for any of those three things. This is sort of slightly more elegant, perhaps. It says, okay, 0 or 1 C. Let's see, what is this? Right. 0 or 1 C, and then 0 or 1 of these. So that's interesting. So, because if we had done, I had been thinking when I was looking at this quickly, is that we could do this. But what's wrong with that? CT. Yeah, it could give you CT, which is not one of the things that was in the list of plots of what we wanted to catch. So this is saying, okay, maybe there's a C or not. And then, so this should be the value to either C or A, and then maybe that whole thing is present or not. So that's the question. Okay, any questions about that one? Okay, so the next one was this one. So we have C, any number of A's followed by a T. Anybody see anything wrong with this one? Okay, so we need a plus instead of star, because the star could value it to 0. It will value it to 0 more A's. So we can, oh, that's down here already. Okay. We don't need the character class because we're just matching the literal A. So this one should work, and this one is not quite right there. And then let's see, what is this doing? So this is, oh, okay, so this person was saying I wasn't sure whether you were asking me to only look for this as the complete line, or whether I was asking you to look for just this pattern embedded within a line. So that's the business with this, same sort of issue over there. But then this is saying, okay, A, one or more times. So that's just a slightly more wordy way of saying putting the plus. Questions or comments about this one? Yeah, no.
Yeah, it looks like for the first one, you could, it's possible that you would get a word that had cat in the middle of it, but had like other words on the outside, because you don't have the character.
Right. So this would, either of these, well, leaving aside the star issue, those would match, what's the word with cat in it? Concatenate, right? So this would match that, because we haven't put anything about either that we're only looking for cat and nothing else, or that we're looking for white space on either side. What's your name?
Mike. Yeah, if we just wanted like 0, 1, or 2 A's or something like that, do you just do that bracket notation with 0, 1, 2? Or how would you?
I don't know if multiple commas will work or not, but you would do it like that, the range 0 to 2. Okay, any other comments on that one? Okay, this one was maybe one of the easier ones. So it's just saying either lowercase d or uppercase, same thing with O, same thing with the G. I'm not sure. Yeah, this is sort of redundant because this is basically saying one or the other of them. So I'm not sure whether this would give an error or whether it just would be redundant to have the symbols in there. Okay, this is interesting. Somebody else came up with a sort of something out of left field, which is don't worry about the pattern recognition, but recognize that if we do graph, there is, well, actually this is probably true for any of the graph or G-regular expression, or these various ones, that there's an argument that says ignore case, in which case that would address this without having to go through the regular expression syntax. Trying to figure out what, so this is, is this some other syntax for ignoring case? Whoever did this, they want to acknowledge themselves and explain this to us. It's not that embarrassing. I think it's interesting. Kudos to you for coming up with something different. Okay, can anybody explain the syntax to me? I haven't seen it before myself. Okay, well, if no one's willing to say, and I realize I've sort of raised the stage here by playing this out a bit, but this is interesting. I haven't seen this syntax before, but presumably this is a different way of ignoring case. Okay, so the next one was positive number with or without a decimal place, decimal point. Okay, so this is saying, okay, any number of digits, so this would say 0 or more, which is interesting because we could end up with a number that looks like this, or we could have a number that looks like that, so we might want to figure out whether we want to allow that sort of thing. So this would allow that. And then we're going to escape the period to make sure that we're literally matching a period, so that makes sense. We're going to say 0 or more of those, right? And then we're going to say 0 or more digits. There's something in here that might or might not be considered a bug depending on what your context is. What could go wrong here?
You could get, like, nothing could match that, because you have 0 or more, 0 or 1.
Okay.
Because you could get nothing. So.
Yeah, that's interesting. I wonder if, what would happen if we actually passed this in as a regular expression, whether it would match anything. That might well be the case. Anything else that we see that one notices here looking at this? Yes, so what's your name? UGF?
Yeah, I think it will pick up the period if you only have one period because in the middle the period is optional and you can have any number of digits.
Okay. Right, so that's sort of variation on what Willie was saying, that we might just match this. We could also just match something like 7 dot, right? And that might be okay. You know, this might be in a sentence that says something something 7 period, right? Or it might be a little bit weird in that usually we wouldn't have a number that looks like this. So it sort of depends on the context of what kind of text it is that you're matching within. Let's see, what else did folks come up with? Okay, so this looks like identical to that, except that we're using the digit class. Looks like there's a missing colon here. Instead of the //d, but that's basically equivalent syntax. And then this is saying 1 or more digit, and then, okay, so there's a period here which presumably needs to be escaped, so we would need to put in the escape in there. Oh, I see, wait, so what, so this is not quite right, it looks like, so why am I saying that? What's missing from this piece of it? Yeah, I need the double brackets because this is just saying what the name of the character class is, but to actually make the class, I need to have a double bracket. So I'm not, let's see, so as we think about this, I think the person probably meant to have something like this. But we also have the plus and the asterisk, so I'm not, again, does somebody want to, whoever wrote this, want to try and explain what they were thinking as they were going through this? And this is not a criticism, just, yeah.
I'm trying to make the dot must be followed by a number.
Okay. Yeah, so that's good, because you were trying to get around the point that Willie raised, that this might not match anything. So the idea is to start to try and think more carefully about what are the things that, so we could, we're thinking about patterns, we could think, okay, just a digit is okay, a digit, and then a period, and then a digit is okay, a period and a digit is okay. Is there anything else that would be okay that I'm missing here? Is anybody saying anything that I'm not? Oh, great, okay. So given that this is what we're looking for, and given the shortcoming we saw in these, we could start to basically try and use parentheses to enumerate that we might be looking for this, or this, or this. And if we're just looking for this, then we would be using a plus instead of an asterisk, and that would probably get around the issue of matching nothing would get a little more cumbersome because we have to have things separated by the pipes to account for these three cases, but that would probably be the direction that we might want to go. And so the idea here was maybe there's a digit. So a digit, and then one or more of either a digit or a period. Is that right? Is that what you were saying here?
No, I was saying I grouped the dot and the digits together to the group, and it could be 0 or 1.
Okay, but you were trying to say one or more digits and then with a period and then zero more of those. Okay. Yeah, so we might be able to be more clever than doing these three. So we're saying there has to be a period or a digit, at least one of them. Okay, so I think, yeah, this is right. So this is a nice solution, I think, because then we're saying there has to be a digit here. So yeah, so I like where you went with this. So we're saying there has to be a digit. It could be preceded by a period or a digit, and it might be preceded by a digit here. Yeah.
Wouldn't you need at least 2 digits then? Because you have a plus in the beginning digit, and you have ending digit.
Then we have a definite digit here.
But if you have just 7.
Right, so that might be an issue there. So we might want to change this to a star. We'd have to think about whether that would work. But I think either this or a very slight tweak on this would probably work and satisfy what I was saying here about possible patterns. Yeah, in fact.
I was going to say that would allow like 7 dot dot 7.
Right, okay. So you start to see how complicated this can get. And at some point, I like this direction of trying to be more sophisticated and elegant here, as opposed to spelling out these three, but this might be the safer route to go, given that we're able to say these are the 3 possible patterns. And I think once we get it down to these 3, it becomes easier to write out the individual regular expressions that match each of these 3 cases. Okay, so let's leave that there. We don't need to come up with a definitive solution, but this was interesting, and I think it brought up some of the sorts of issues that come up when you're trying to develop these. And for me, at least, I work with these occasionally. It's not something I do as sort of the main part of my job. So I always end up having to play around and try things out and do it on a test case and see what goes wrong, and then I go back and I fix it and I sort of iterate like that. Okay, so the last one was any line with 2 words separated by any amount of white space. Okay, so we've got white space here, 1 or more white space. So this is interpreting white space as spaces or tabs, which you can think about whether you want to include a new line in here as potentially white space. Often you would not want to do that. And then we have any alphabetical characters, 1 or more, and then again white space possibly at the end, white space possibly at the beginning. So that looks pretty good, I think. Okay, so this was just trying to match on a space and it left out the tabs, so that's fine, but we probably, in some contexts at least, we would probably want to include the tab as well. Anything that anybody notices that might go wrong with either of these?
Do you require that it's occupy the whole line?
Right, so that's right, let's see, so this one would be saying that it would have to be only 2 words, right? Is that right? Am I getting that right? Is that what you were
So
asking?
that the hat and dollar sign is looking for.
Right, so that's looking for this at the beginning and this at the end, and then we're only indicating 2 words. So presumably, if we have 3 words matched by white space, this unless I'm missing something, I don't think that would match that. So it sort of depends on how you interpret what the question is. Anything else that folks notice with this one? Yeah, Tom.
There's a class
yeah, so that might be a good way to go instead of enumerating the character class by sort of exhaustively. It's not very exhaustible now, we only have 2 things in here, but we might instead use blank in there. And it'd be interesting to go and look and see what's in blank, if there's anything other than a space or a tab.
So the regular expression is comparing line by line, right? And if I have
Well, in R, hold on a second. In R, it's going to take a character vector as the input. It's going to look at each element of the character vector. So
in general, that's going to be line by line.
no, because the character string might have a new line in it. So I could tell R, text gets C of AB and A/NB and whatnot. And this has this has 2 lines in it, but this would be treated as a single string by R. Oh, okay. Yeah. So one thing I was thinking of when I was seeing this, and then I forgot it for a second, is this doesn't account for apostrophes. So we might want to think about whether there's anything else that can be in a word that would still allow it to be a word, but that's not just an alphabetic character. So you might want to extend this to include an apostrophe in here. And I think if we start with double quotes here, I think we probably don't need to escape that, because there's a possibility we might need to escape that single quote as well. Okay, any other comments or questions about any of these? Yeah.
In mine, I also accounted for possible punctuation. Like if you had like just a 2-letter question or a 2-word question, like a question mark at the end.
Oh, okay, so you were saying maybe you might have a word, a space, a word, and then a punctuation at the end. Okay, yeah. So we could also, then it sort of gets down to what exactly are we looking for in the given context. But then, these sorts of tweaks are things that we would want to be thinking about as we're thinking about the problem. Anything else? Okay, so let me, we're just going to finish off the regular expression bit here. I have one other thing. Sorry about the noise. One other complication to mention, which is this thing called greedy matching that we should talk about. So basically, greedy matching is that in general, regular expression implementations are going to look for basically the longest string that will match. So let's see an example of that, and it often takes a little bit of sophistication and recognition to know that this is going to happen and figure out a way around it. So for example, suppose I've got an HTML file. This is the sort of thing that comes up pretty frequently, and I just want to strip this down and get rid of the HTML tags for some reason. I just want to reduce this to plain text. Right? So the tags are of the form, like this, and then the ending one is with the slash in there in front of whatever the syntax is. So my idea for solving this to strip out the tags was to say, let's look for a less than, and then any number of characters, and then a greater than, and just replace that with nothing. Okay, so that was my solution to do this, and I was thinking, oh, that should match this, or it should match this, or maybe if I have HTML in the brackets, it should match that. So I was thinking, oh, that looks like it'll solve things. But if I do that, what you'll notice is it stripped out, it gave me back internship all the way to of. It stripped out everything from internship to here, is that right? Yeah, of their courses. So what was happening is it's doing greedy matching. It finds this. It then finds any number of characters, and it included in any number of characters the greater than sign that I was thinking would end it. So it just keeps marching along. These still count, these still count, these still count. It gets to here, and this is the last one, and it's able to match on this one, and then it has to stop here because it can't find one of these any later on. So it's stripping out all the way from here to there because it's doing this greedy matching. So one way around that, and I sort of hate this syntax because it introduces question marks in a different context. Like this is, to me, is like sort of the worst thing about regular expressions is some of these symbols get used in multiple ways and it just matters exactly where they are. Is you can append this question mark and that says don't be greedy about matching this any character syntax here. So if we did that, then this actually works, and it just strips out the the actual HTML tags and not anything that's sort of embedded between things the way that we saw a minute ago. Okay, so any questions about that? Yeah, Dustin.
Wouldn't you want to include like a white space in your regular expression so you can move like the double spacing?
Yeah, certainly if I were being more elegant and taking more time with this, I would be wanting to think about the fact that when I remove these, there ends up being 2 spaces instead of 1. I could do that either in the regular expression, or I could do a second step of processing that says, look for any repeated white space and replace it with just a single white space, for example. Any other comments or questions? Yeah, Alex.
When you say it's not greedy, like what exactly does that mean? What algorithm is it using for matching?
You mean in terms of the greediness?
Yeah, because I mean, what if you had like open bracket, a bunch of rows? I mean, does it automatically pick the shortest one? Is that how it works?
Well, I mean, I think what it's doing is it's basically, it sees this, and that it knows that starts the pattern, and that says, look for any number of characters followed by, this one, any number of characters followed by that, and and I don't know exactly how the algorithm works under the hood, but it's able to just keep marching along until it gets to this, because these other ones are matching the fact that it can look for any number of
So
characters.
the default behavior would be to find the longest. So,
Right.
So if you put the question mark, is it then finding the shortest?
Yeah, I believe that's what's happening. Is it's basically saying don't be greedy. So as soon as it reaches one of these, it's going to terminate. So I mean, so this for me sort of actually this is a good lead into what I was going to say next, which is to me these seem a little bit opaque and sort of bring up some of the issues that you've been bringing up. So let me pose the next question to you guys, which I have in the PDF. Which is, how would I actually write this, instead of using this with that symbol in there, how would I actually write this to avoid having to deal with the greediness in this way? So take 20 or 30 seconds and see if you can think about what I would need to do to avoid the greediness without using this new syntax that we just discussed. All right, any thoughts on what we could do? Yeah, and remind me what your name is?
Darren.
Darren?
The chatting inside cannot have any bigger than thing.
Okay, so let's start to change what we, the problem that we ran into here is this is just too darn general, right? Okay, so what more specifically do you want to do to replace that?
So use the negation of the bigger than thing.
Okay, so if we do this, and then we would want to say, I guess depending on what we think about what the HTML syntax is, we would either want to use a star or a plus. So let's stick with a star, and now we've got this and then this, and so that should get around the greediness by being more explicit about how we want what's allowed inside inside these guys. So personally, I think this sort of solution is more elegant and probably cleaner than using that question mark operator like that. Yeah.
I do have a question about the don't do the greediness. So the question mark goes with the bigger than symbol. So if I change the bigger than symbol to be like I in the previous example, would I stop by say E or like internship or somewhere?
So sorry, I sort of lost you somewhere.
So if I change the bigger than symbol in the
Here?
yes, then where would I stop in the example?
If you take this out?
Yeah, and try to whatever character which is in the original sentence.
Yeah, you're sort of catching me a little unprepared here because I try to sort of, as I've already stated, I try to avoid using these question marks generally. So you're saying what would happen if I just do this?
The next.
Oh, right. Sorry. If I do this.
Or no, let me put like I. Character I.
Character I?
Yeah. Then would I stop by the in place?
Okay, so let's try that out. So it is So what have we just done? We've said, look for this, any number of characters, and then stop with an I, but I think this is saying don't be greedy about this. So in place, so then it matches this, and it gets to the I. Oh, right, so it just, so yeah, it wasn't greedy, because it stopped as soon as it got here, and this is where the end place came in.
Thank you.
Okay, other questions or comments? Okay, let's see. Let me say one more thing about replacing stuff. Let me set it in the following context, which is suppose that I had an R character vector, and in each of those elements of the character vector there might be an email address in there. So if I wanted to just pull out only the email addresses from each of those, then I can't. Then I could use G regular expression followed by reg matches, and I showed you that syntax. I didn't dwell on it for very long, but I should be able to use that to pull out just the email addresses. But the other way you could do it is you could basically, if you do something like, if we're writing a pattern in and you did something like this. And if in here you had what you expected to match the pattern of an email address, and in here you had, well, I guess you wouldn't necessarily need the parentheses, but you could have something like, where'd my eraser go? And then if you had something like not an alphanumeric, and if this were sort of something similar over here, and actually now there's only one parenthesis left, so let me do this with one. Basically the idea here is if I can include in the pattern that gets matched all the stuff that I want to exclude and the stuff that I want to include, and then I delineate the stuff that I want to include with parentheses, then I should be able to replace the entire pattern, which should match the entire line, with just the piece that I'm interested in, which is the piece that's enclosed in the parentheses. So this would be another way to pull stuff out and get rid of the extraneous stuff that I don't want, as well as using the G regular expression combined with the reg matches. So I just wanted to point out that you can do things like that, and you just need to be careful about making sure that you're matching everything and then carefully specifying what's the piece that you want to extract. Yeah, Julia?
What if there's another set of parentheses inside of this parentheses, so it's like a nested, which one would it pull out?
Yeah, so that was actually a really good question that I was glad somebody asked on the Piazza site, because I hadn't realized that that functionality worked. So if you do something like this, and there's some stuff in here and there's some stuff in here, what it looked like from when I was just playing around with it empirically was //1 gets matched to that and //2 gets matched to that. And so you can actually do some fairly sophisticated things with picking up longer things that have other things embedded within them. So I haven't actually used this myself, except when I was playing around with this yesterday or the day before in reaction to the question on the discussion site. But that seems like something that could, in certain contexts, be quite useful. Okay. So I just have one final comment about using regular expressions, which is basically that you can use them in lots and lots of different contexts. I've already said you can use them outside of R and inside R. There are lots of contexts you can use them outside of R. But even within R, you can use them with other functions other than the ones that we've mainly been focused on. So for example, here's an example where if I'm going to do a string split, and I want to do the string splitting with a regular, I want to say that to use a pattern as the splitting information. So I can pass in a regular expression to the string split function as well as the other functions that we've discussed. And there are going to be other cases where you might be working with various functions and realize, oh, it will take a regular expression as an argument, and so these are useful fairly broadly. And then just to point out, maybe I should have put this at the beginning of the notes for this section, but this is just trying to give a summary of the different syntaxes that we've and different sort of language pieces in this regular expression language. So that's all I have on regular expressions. You guys will be working a lot with them on the last problem of the problem set, so I'm sure there'll be lots of questions and discussion as a result of that. But are there any other questions at this point? Okay, so let me switch to Unit 5. I'm just going to say a few brief things about this, and then we'll move on to Unit 6, although given time we may not start on that until Friday. So in section on Monday, Tessa already talked about section 2 of this, which is using R's debugging tools. So you've already had an introduction to that. We're going to talk about basically good practices for writing your code, some in section on next Monday, as well as sort of more general good practices for writing code and doing analyses and developing software. So we're going to hit some of the highlights of some of the items that are in these other sections of this unit next Monday. And I will ask you to make sure you've read through this before Monday. In fact, I should make a note to myself to just post that reminder on Piazza. The only thing I want to point out, I think the only thing I want to point out here in terms of some R functionality is dealing with errors when code actually runs and trying to write robust code. So those of you who were in the boot camp a few weeks ago saw some of this already, but I basically want to sort of give a big picture overview of what it is that we're trying to accomplish with these functions. So the functions that we're talking about here are stop and warning and stop if not and try. So these are all functions that are quite useful for making your code more robust to errors. And the idea is basically that if you're writing a function, you'll often want to have some lines at the beginning of the function that check that the input is compatible with the code that you then write later on in the function, so that to make sure that the user is not passing you something that you can't handle. And more generally, if you're doing a data analysis, you might want to put checks in there to make sure that there aren't missing values, for example, or there aren't values that are numerical values beyond the range of what you're expecting. So there are lots of different contexts in which it's a good idea to put these checks in to make your code robust so that your code doesn't just fail without giving you an informative error message. And so often what you'll do is you'll put an if statement in there, or you'll use this stop if not function. And you'll put an if statement in there, and if the result of the if statement is that you found something unexpected, like you were expecting the user to pass in a vector of numbers, and instead you got something that was not a vector of numbers, then you would then use the stop function to stop the code and write out an error message that tells the user that they passed in something illegitimate. Or if they pass in something that you can work with, but you're not sure that that's what they intended, that would be the place where you would have an if statement, and then if you found something unexpected, you use warning instead of stop. And these are the functions that that the built-in R functions use. Whenever you see a warning message or an error message, they're calling warning and stop, and you can use those functions as well. So I won't go through this in any detail, but as an example in here, I just wrote a little square root function of my own, which sort of mimics the R square root function, and it goes and uses if statements and does some checking to make sure that the input is what is reasonable in order to pass into a square root function. And if it's not, then I give an error message that says something about what went wrong. And then the other thing I want to mention in this context is this function called try. So the basic idea of try is that if you're about to call some other R function and you think that there may be situations in which when you make that call it's going to spit back an error, but you don't want your code to just flat out stop at this point. You want it to continue. So for example, suppose you're in a for loop, and even if one of the iterations of the loop fails, you want to be able to continue executing the other iterations of the loop. The way that you can robustly handle errors of that sort is to wrap the call that you're making that you think might fail and might give back a stop, an error. Wrap that in a try, and that will basically catch the error and allow the code to continue operating. So I also probably won't. Well, let me just say what I'm doing here, because try is a useful thing to know about. So basically, what this is this is basically just setting up some data. But the idea is I'm going to set up a matrix, and for each column of the matrix, I want to fit a distribution to that column. This is this gev.fit function is something that fits a particular kind of distribution called an extreme value distribution. And in some cases, when you fit these extreme value distributions, the maximum likelihood estimation doesn't converge, and so you don't get a result, and it spits back an error. So the idea here is I don't want my code to just flat out fail when it reaches a column under which it can't fit the distribution to the data in that column. So I'm going to write a for loop and loop through the columns and try and fit each one of them. But instead of just you doing gev.fit, which would fit the data in the column, I'm going to wrap that in try so that if the call to this function fails, then I still am able to continue and work and do the fits to the remaining columns. So fit, the result of this, if this succeeds without an error, the result of this is just going to be what it normally would be. But if this fails and if gev.fit were to inside itself call stop, which it does if it doesn't converge in terms of the maximum likelihood estimation, then it's going to give back an object here that has the class try-error. So I'm just going to do a little query that says if this fit thing is not a try error, then I'm going to save the resulting MLE, the parameters, to some object that's saving the output. And otherwise, you'll notice that I set it up so that params was just full of NAs. Otherwise, I'm not going to do anything, and there'll just be NAs left in that position for that column. So that's the idea of being robust to those sorts of errors. So we could see if we can run this quickly and just see how that goes. Okay, I'm going to set up. Okay. Let me try that again. Okay, so I've set up params such that it's just filled with NAs. This is a case where I just have three. What have I got here? What's the dimension of x? Oh, okay. I guess I just set this up with two columns. So now if I run this, so now if I look at, so you can see there was an error spit back. But the error occurred in the first, so this is a little confusing because I think what I've done is I've put the params for the first column here, the MLA for the first column here. So the data is set up by column, but now the parameters are getting sent back by row. So that's a little bit confusing. But you saw that there was an error. This happened on the first column of data, and so but it was able to handle that robustly and then give me back the result for the second column. So this actually then went ahead and worked. Whereas if I didn't have the try in there, it would have just failed after the first one, exited out, and I never would have gotten the result for the second column of data that in this case gives me those estimates. Okay, so any questions about that? Okay, I want to make a brief mention of this, this is just sort of a helpful tip that often causes problems for me. So basically, when I'm thinking about running analyses, I try and follow a couple practices with regard to this. One of this is if I'm doing some long pipeline of work, I will try and save the intermediate results, because oftentimes as I'm developing the code and doing the analysis, I'll end up finding out that there's some error at some later stage, and if the pre-processing took many hours to do, I won't want to have to go back and redo the whole process. So it's nice to save sort of intermediate results. It's always good to set the random number seed so that you can recreate exactly what the code was, because sometimes you'll see that things will fail, and then you won't be able to recreate that error because you got a different stream of random numbers the next time you did it, and sometimes the failure depends on exactly what the random numbers were. So setting the random number seed initially is also always a good idea. And the other thing I'll mention, and this is something that sort of happens to me all the time, maybe I'm just sloppier than most people, which is that I'll have some piece of code that runs for a long time, and then at the end I'll save the output in some way. And there'll be a bug in how I save the output, and so I'll run all the code. It'll take in a few hours, and then I won't get any output back because there was a bug in the code that does the saving of the output. And sort of more generally, it's a good idea to run through your code with a small if you can, a small subset of your inputs, and make sure that it runs correctly and saves the output correctly, and then only do the real run on the bigger data set after you've made sure that the code actually works and runs through correctly. Okay, so I think that's all I want to say. We're going to talk more about reproducible research and these other topics in this unit in section, in part based on those readings that we've asked you to do. So we'll come back to these topics then. Okay, so let me go on and just give a little intro to where we're going in terms of Unit 6. I won't have too much time to say things here, but we'll pick this up again on Friday. So basically, we're going to go through, unlike Unit 4, we're going to go through Unit 6 essentially fully in detail. I'm not going to be skipping over so much stuff. And the idea was that Unit 6 in some ways contrasts with Unit 4 because it gets into some of the more, sort of more into thinking about programming and actually some of the considerations that you would run into when you're writing programs. But in some ways, there's not a clear break between the material that was in Unit 4 and the material that is here in Unit 6, and that's in some ways just a historical legacy of how I've developed the class over the last few years. So you can sort of think of these two units as going together pretty closely. So the first thing I want to talk about in terms of Unit 6 is to spend a fair amount of time on thinking about writing efficient code in R. And there are a number of different strategies that we can take to make sure our code is efficient, and that's going to, in some cases, it's going to speed up our code by one or more orders of magnitude. So that it really can make a big difference in terms of how you write your code and making sure that you do things in a smart way. I will make a caveat about that, which is I often think a fair amount about efficiency because of the work that I do, which is often fairly computationally intensive. But in some cases, you may not need to worry about it. You know, if you're writing some code that takes 10 seconds to run, you probably don't need to spend a lot of time figuring out if you could save a second here or a second there if it's just something you're going to run once, right? You might spend 10 minutes or an hour saving 3 seconds, which is probably not a good use of your time, unless you're going to be developing software that you're giving to other people and that you or other people will be running repeatedly, in which case saving that few seconds might, in that case, make sense. So, so try and be thoughtful about when it makes sense to put a lot of your time and energy into writing the more efficient code. The other thing is, it's one of these sort of principles of good coding practice is not to try and optimize too early in the process. So write your code in a way that feels natural to you, that you think is going to be least likely to have errors in it. And then after you've got code that you're pretty sure doesn't have any bugs in it, then you can worry about optimizing it and making it more efficient. So that's one way of thinking about this. And once you've got the code that you're pretty sure works that's slow, you can write the version of the code that's faster, and you're now able to run both of those sets of pieces of code and make sure that you get the same result from both of them. So that's a good way of checking that the fast code is also good code in the sense of not having bugs. And sort of lost track of my train of thought. The other thing I was going to say as my last comment is just that doesn't I just said sort of write the code in the way that you're comfortable with, and then think about making it faster. I wouldn't say that that's necessarily an argument for using for loops all over the place, for example, because I can write very short code that uses factorization or uses an apply. And if you're used to using that code, that's going to be you're at least as likely to not have any bugs in that code as you are if you've written a for loop. So that's not necessarily a reason to write code in a really verbose way, because often shorter code that uses sort of the principles of R coding is actually going to be code that's more likely to be bug free. Okay, so let's quit there, and we'll pick up with this in terms of details on Friday.